In this video, we are going to go over the steps of finding a missing side length in a right triangle. So, in a right triangle, in order to solve for a missing side, you need two things. You need one of the angles that is not the right angle, all right? So, one of your reference angles. And you need one of the sides. It can be any of the three, one of the sides. If you have those two things, you have enough info to solve for a side in your right triangle. Now, listed below are the steps that we're going to use to solve these, and I'll do the examples here in a second. So I'll kind of reference these steps as we go through the examples, but first we're going to label sides, just like we reviewed in the couple slides before this module. Then we're going to identify which trig function to use, which, once again, we also reviewed earlier in this module. And then we are going to set up an equation and solve it. And that's the new part that we got to kind of go over in this lesson. So let's go to the examples. So here are the two examples that we're going to look at. As you can see, they're kind of separated in two separate parts when x is the numerator and x is the denominator. Reminder, the numerator is the top part of your fraction and the denominator is the bottom part of your fraction. So for both of these, we're going to go over kind of the prerequisite steps that we did earlier in the module, and we're going to go over kind of the new solving steps. So we're both going to set up both of these, and then we're going to talk about the solving part together. So as we look at the one on the left side here, the x is the numerator. We are going to first label our three sides, which we practiced earlier. First, we have the side across from the right angle, my hypotenuse. Now, our reference angle for this problem is the 30 degrees. So 30 degrees being our reference angle, we are going to make the opposite side, the side across from that 30-degree reference angle. And then that leaves this bottom side right here, the x, our adjacent side. So there's my opposite, adjacent, and hypotenuse sides. That's the first step, identifying your three side types. Now, the next piece that we have here is we have to identify which trig ratio we're going to use. And this is where we're going to use SOHCAHTOA that we talked about earlier. So I'm going to write this again up top. We have SO, which stands for sine, and then opposite over adjacent. You have CA, the C stands for cosine, and the A and H is adjacent over hypotenuse. And we got our T for TOA, tangent, opposite over adjacent, SOHCAHTOA. So I'm going to leave that up there for reference as we go through these two problems. So we have to identify which one to use, and that is going to be kind of the important thing here. So as I go through these, if you take a look, my hypotenuse is 186 feet. Like, I have that value there. That's the only number side that we have. The part that I'm trying to find is x. That's what my instructions say, right? Solve x, okay? That is the adjacent side. Now notice how, unfortunately, I do not have anything for the opposite side. It's not x, it's not anything given to me. There is nothing going on over here. So when I'm looking and deciding which trig function to use, if I have the hypotenuse and I'm trying to find the adjacent, A and H are the two letters that I need to use in this trig ratio. So that leads me to cosine. So for this problem, I'm going to use cosine. That's step 2, identifying which sine, cosine, tangent you have to use, and it's all based on which sides they give you, okay? So the last part is going to be our setup, and then we'll do the solving, like I said, kind of for both problems together. So for our setup here, we are going to, let's pick a new color here, let's go orange. We decided that we're going to use cosine. So I'm going to abbreviate that COS, like we talked about earlier in the module. Now, the angle goes on the inside here, reminder. My angle is 30. I should have a number here because to do these problems, you got to be given the reference angle. So I got cosine of 30. I'm going to close my parentheses, and then I'm going to set an equal sign, and now I'm going to put my ratio. So we know that cosine is adjacent over hypotenuse, so that order matters. When I go to write this fraction, I have to put A, which is going to be x for this problem, up top, and the 186 goes on the bottom. There's the setup for this problem. Our last step will be solved. Once again, we'll do that in just a second. Now, over on the right side, x is the denominator. We're going to do the same thing real quick. So let's label my sides. Across from the right angle, hypotenuse. My reference angle is going to be the 23 degrees. And so my opposite side is across from that. And that leaves the adjacent side to be the side next to the reference angle. That's not my hypotenuse. So boom, right there. So now as I go through and see what sides I have to identify which trig function to use. So same thing. As I go through and look at this, okay, look, I don't have a hypotenuse. There's nothing going on here, okay? It's not what I'm trying to find. I don't have a value. And then look, your opposite side's 55 centimeters. That's what they give to us. And x is what we're trying to find, the adjacent side. So for this one, we want to use O and A, which leads us to tangent. So this problem is going to be a tangent problem. So we're going to write tan, the abbreviation for tangent. Our reference angle is 23. And then we're going to set that equal to our ratio. And notice, look what happens this time. Hence, x is on the denominator. It's O over A. Our O is 55. And our A is going to be that x that we're solving for. Now I'm ready to go. Now I'm ready to solve. So notice the two main differences here are over here, x is in the numerator up top. And over here, x is in the denominator on the bottom. Okay, so last part we're going to do for these problems is we're going to do the solving. So for the solving, what I need you to do is I need you to go ahead and get out a calculator. Now, I recommend using Desmos. You can either pull it up on your computer, you can use a phone or tablet. I have an iPad that I'll be using Desmos on, but you need a calculator to do these problems, to solve these, okay? Next thing I need us to check is our calculator in degrees? Since that is how we're measuring our angles in these problems, we need to be in degrees. So I know in Desmos, if you hit the wrench in the top right corner and you make sure that degrees is highlighted, that's how you're going to check that. On various calculators, there's going to be a DEG button. So if you're using an iPhone, if you're using a scientific calculator, okay, you'll look for something that says DEG, okay? Now, obviously, there's a bunch of different calculators and stuff you can use. So if you're having trouble finding out if my calculator is in degrees or not, okay, guys, you can search the internet for it, okay? Search whatever program you're using, whatever type of calculator you're using. Put the model in there, and if you search it on Google, it will 100% give you how to put your calculator in degrees and make sure it's in degrees. Because if you do these problems, you can do these problems entirely correctly, but if you're in radians, it's going to give you a different answer than what I get, okay? If you have any questions, shoot me an email, but make sure your calculator's in degrees. So, to finish up this lesson, here's what we're going to do. Now, you need the Algebra 1 skill, all right, of remembering how to solve a proportion. So here's the thing. Cosine of 30, it looks really weird right now because it has three letters, right? COS and then parentheses 30. If your calculator's in degrees and you type in cosine of 30, now there's usually a button that says COS. In Desmos, if you click the functions button, it goes to cosine. And if I type in cosine of 30, look, it gives you a number, 0.866025. That's because that gives you the ratio that cosine of 30 should follow. So we want to treat it like that's a normal number. So I'm going to put that over 1. And what we're going to do is we're going to cross multiply to solve this proportion, this ratio, proportions, two ratios equaling each other. So we have 1 times x and cosine of 30 times 186. So it doesn't matter which side you put each one, but 1 times x gives me x. And then I'm going to write out cosine of 30 times 186. And guess what? That tells us what we need to type into our calculator. So you know how I had you just type in cosine of 30 into your calculator and show you that it's a number? Well, guess what? We are just going to type in cosine of 30 times 186. So in my calculator, cosine of 30 times 186. And when you type that in, you should get a 161.080. Now, we're going to round to one decimal place, the 10th spot, because we get a pretty long decimal, and we're just going to make this 161.1. We are in feet, so let's go ahead and add those units. Boom, there's my missing side length. So notice how when x is in the top, in the numerator, you cross multiply, and what happens is you end up multiplying your trig function with your number times another number. Now look what happens in the second part over here when I have a trig, or excuse me, when I have x on the denominator. So I can do the same exact strategy of putting this over 1 and cross multiplying, but look what happens, a little bit different. I get 1 times 55, which is 55, equals tan of 23 times x. Now, obviously, this looks a little different than what was going on in the problem on the left side, right? I can't just multiply tan of 23 times x. X is what I'm trying to find. So the reason why I like writing it like this is because now I can solve this like an equation you solved in Algebra 1. If you remember that tan of 23 is just a number, then it's really just a one-step equation. You can divide by tan of 23, and guess what? It's an equation. You do it to one side, you got to do it to the other. Please excuse my slow writing. And now look what happens. On the right side, if you divide tan of 23 by tan of 23, that's going to cancel out and give you x on this side. And then over on the left side, look what you get. 55 divided by tan of 23. Guess what? That's where we can use our calculator. If I take 55 and divide it by, I'm going to click the functions button on Desmos and hit tan. If you're using a calculator, there should be a TAN button for tangent. I'm going to type in 23, close that parentheses, and take a look. 55 divided by tan of 23 gives me 129.5718. We're going to run that to one decimal place and make that 129.6. And boom, there is our final answer. Okay, we are in centimeters, so I probably should have added that. Sorry about that. Centimeters. Okay, and that is how the solving is different from based on x in the numerator versus x on the denominator. So now you're going to have some time to practice this. Please use this video as reference. Please reach out if you have any questions.